In this video, we will introduce the Simplex method using a Simplex Tableau. Let's look at this example. We want to maximize the value of p, which is 25x1 plus x2. For both of the inequalities in the problem constraints, we have the less than or equal to sign. First, let's talk about the initial system. Adding S1 and S2, we can turn these two inequalities into equations. Now we're going to move all the variables in the objective function into one side, and that becomes our third equation. Now, adding the non-negative constraints, we completed our initial system. Now let's turn these three equations into an augmented matrix. And that matrix is called the initial simplex tableau. This is how the initial simplex tableau look like. Now let's select the basic variables and the non-basic variables. S1, S2, and P are basic variables because there is only one non-negative element in each column and the rest elements are zeros. And also those three non-zero elements are not in the same row. And the rest two variables will be the non-basic variables. So x1 and x2 are non-basic variables. The row, the basic variable s1 is not equal to 0 is called the s1 row. And similarly, we have s2 row and the row of p. Draw a line here to separate the problem constraints and the objective function. We're going to do some operations later so that we will swap the non-basic variables x1 or x2 with one of the basic variables s1 or s2. We'll never swap for p. That means one of the x1 or x2 will become a basic variable while one of S1 or S2 will become a non-basic variable. To do that, we need to go through a bunch of process. First, we need to decide what is the pivot column. Let's look at the bottom row, the row of P. There are 4 elements to the left of the P. They're negative 25, negative 1, 0, and 0. Those 4 elements are the indicators. Now let's find the most negative indicator. That means let's find the negative indicator with the biggest absolute value. In our case is negative 25. The column this negative 25 is in is called the pivot column. In other words, x1 is the pivot column. There are 2 elements above the line in that column. One is 2, the other one is 1. One of them will be the pivot element. One thing we need to know is that a pivot element must be positive. Well, since both 2 and 1 are positive, how do we decide which one is the pivot element? Well, we will make the decision by doing a comparison. So first, we will divide this 12 by this 2 over here. So 12 divided by 2 will give us 6. And then we will divide the 12 here by this 1, which will give us 12. The row with the smaller quotient, in this case is this row, is called the pivot row. What pivot column and pivot row have in common is the pivot element. In this case, 2 here is the pivot element. Since 2 is in the column of x1, so x1 is called the entering variable. Since the pivot element 2 is in the row of S1, then this S1 is called the exiting variable. We will do some operations later so that the entering variable x1 will later become a basic variable, and the exiting variable s1 will become a non-basic variable. In other words, we will swap the row of x1 and s1 over here. The operations we will perform on this matrix is called pivot operations. It is very similar to row operations, except we cannot interchange two rows. Our goal is to first make the pivot element 1 and the other two elements in the column 0 by performing pivot operations. So first I will make the first row 1 in the pivot position. So R1 needs to be multiplied to 1/2. I'll make it the new R1. And the rest two rows remain the same. Now I want to make this 1 0 and this 25 also 0. So the row operations I will have is add negative R1 to R2 to make it the new R2, and add a positive 25 R1 to R3 to make it the new R3. R1 stayed the same. This is what we have after the row operations. After this operation, x1 has been turned into a basic variable and s1's been turned into a non-basic variable. So now the basic variables are x1, s2, and p. The non-basic variables are s1 and x2. We'll set the non-basic variables into 0, so that means these two columns are useless to us. Since there are no negative indicators anymore, we can see all the indicators are positive. P equals 150 is the maximum value. It happens when your x1 is equal to 6, and we already know x2 is set as a non-basic variable here, so x2 is equal to 0.